Hello everyone, welcome to a new lesson on trigonometry. And in the last class we have already learned about angles and measurements, okay, and different types of measurements of angles. Today we will learn the sign of different trigonometric ratios, t ratios. Check this out, or we say it to be the quadrant rule. Okay, so before we proceed to the actual quadrant rule, I want you to look at this table carefully. I suppose you are already aware of this table. You already know about this table. The five different angles you see here are the standard trigonometric angles. In class 9 and class 10 we have already done this trigonometric table and we already know the values of this trigonometric table. Okay, so 0 degree, 30 degree, 45 degree, 60 degree and 90 degree are called the standard trigonometric angles, and these angles have their respective values. So let us revise the values of this trigonometric angles. Okay, so the first one, sine 0 degree, everyone, 0. Sine 30, half. 45, 1 by root 2. 60, root 3 by 2. 90 is 1. I suppose you are already aware of this sign values, isn't it? Cos will be just the reverse order. Okay, 90 will be written here, 1 will be written here, root 3 by 2 will be written here, 1 by root 2 same thing, and half and 0. Did you see? I have just written the values of sine from right to left. Then tan, just divide sine with cos. 0, root 3, 1 by root 3, sorry, 1 by root 3. Let me write it properly. 0 and then 1 by root 3, yeah, and then 1 and then root 3 and then undefined, because 1 divided by 0 would be undefined. Cosec, you just have to flip sign. By the way, before cosec let's write cot. Cot will be the reverse of that. Undefined, root 3, 1, 1 by root 3 and 0. I have written tan, the values of tan from right to left. Then comes cosec. What is the value of cosec? I just have to flip sign, so it will be undefined, because if we flip 0 it will become 1 by 0, then 2 root 2, then 2 by root 3 and then 1, and then finally 1 2 by root 3 root 2 2 and undefined. So I have just written the values of cosec in the reverse order. So these are the 5 standard values. I suppose you already know this table. Even if you do not know, you must actually. These are the 5 standard trigonometric angles. We have already done this in class 9. Okay, but now today what we do is we will have to add some more angles to our table. Okay, so let me show you how. So let me draw the quadrant. So this is the x and the y axis, isn't it, everyone? This is called the x axis and this is called the y axis. So you know, this side is positive, here it's negative, this side is positive, and this side we have negative values. Got it? So this is the coordinate axis. Okay, what do you call these spaces? These 4 spaces are called quadrant. This is the first quadrant. This is the second quadrant. This is the third q, that's the third quadrant, and this is the fourth q, that's the fourth quadrant. Okay, in terms of angle, how much angle does the whole quadrant cover? The whole quadrant covers how much, everyone? 360 degree. Everything covers 360 degree, everything, isn't it? But if we divide 360 degree, suppose I'm saying that everything is 360. If we divide 360 degree, then how much do you get? We'll divide it by 4 and each quadrant will be now 90 degree each. So this much will be 90. Let me write it down here. So from here to here would be 90 degree, isn't it? So this will be 90 degree. Let me write here. From here to here, one more 90. That means 90 plus 90 will be 180 degree. From here, 180 plus one more 90, and that gives me 270 degree. And finally from here to here, you can say 270 plus one more 90, that's 360 degree, or back again I can say 0 degree. Got it, everyone? Yes. So did you understand? So what we are going to do till now, our values, whatever we knew about the trigonometric angles and values, the 5 standard angles were all lying in between the first quadrant itself, because 0 degree is here. Check this out. 30 is here, 45 is here, 60 is here, and finally 90 is here, isn't it, everyone? Check this out again. 0, this was 0 degree, this was 30 degree, this was 45 degree, this was 60 degree, and finally this was 90 degree. These were all the 5 standard angles that you knew. But apart from that, we need to add further now few more angles in class 11. That is what our syllabus includes. Okay, so we have to also do angles apart from these 5 standard angles, and that is what we are going to do today. So we are going to add 3 more angles. And what are those 3 more angles? 180 degree, 270 degree, and 360 degree. These 3 angles we are going to add in our standard trigonometric table. Okay, we are extending our trigonometric table. So let us include these 3 values. So it will be 180 degree, 270 degree, and 360 degree. And 360 means exactly 0. Got it, everyone? So let's check it out, everyone. 360 means 0. So the values of 0 will be the values of 360. So whatever the values are here, same will be the values here. So it will be 0, 1, 0, undefined, 1, and undefined. So same values for 0, same value for 360, because 0 and 360 are exactly the same. Got it? What about now 180? Check this out. What will be the values of 180? Whatever are the values of 360, or 0, you can say, whatever are the values of 0, the values of 180 will be exactly the same, but the sign will be reversed. Okay, so let's see. Whatever values are there in 0, same value, sign reverse. So 0 will be 0, no sign reversing. Okay, and then 1 will become -1. Got it? And then 0 will become 0, then undefined is undefined, then -1, and again undefined. Got it? So these are the 6 values I have already written. 180 is reverse of 0. Whatever you write in 0, in 180 you just have to write the same values but opposite in sign. Finally, what about 270? You know the logic, same thing. It will be reverse of 90. Same values but opposite in sign from 90. Okay, so what are the values in 90? 1, 0, infinity. So check this out here. I'll just highlight it. 1, 0, undefined, 1, undefined, and 0. So just write the same values but the opposite sign. So -1, 0, undefined, -1, undefined, and then 0. Got it? So 0 and undefined, the sign doesn't change. So did you understand till here? So I want you to pause the video right now here and then copy this extended trigonometric table in your exercise book or your formula book, whatever you have. Did you understand? Okay, so copy this. So pause and copy this video in your notebook. It is very, very important. Okay, you have to remember this standard value. 0 to 90, you already know about it. Extend it to 180 to 360. Okay, great. After you have done that, now after you've copied the standard trigonometric table, now let us come to the actual quadrant rule. What does the quadrant rule say? Now I want you to write quadrant rule. This is actually the quadrant rule. And then check this coordinate axis very, very carefully. Check this figure. So now have a look. What will happen here is, in quadrant rule, whatever angles you knew in class 10, till class 10, 0 to 90, was all in the first quadrant, isn't it? So let me show you with another color. So this were the values that you were aware of till class 10. These green highlighted ones, isn't it? The green highlighted ones are the values or the angles that you are aware of till class 10. So check the sign of all these values. All the values are what, everyone? Positive. So everything will be positive in the first quadrant. Between 0 to 90, everything will be positive. So I'll write here all positive. All the trigonometric ratios, whether sine, cos, tan, cot, sec, cosec, despite of whatever they are, everything will become positive in the first quadrant. Okay, but after first quadrant, the rule is not going to remain the same. Remember that. In the second quadrant, interesting. Now let me tell you, only sine will be positive. What will be positive, everyone? Sine. But if sine is positive, obviously its partner cosec will be positive. So sine and cosec. In the third quadrant, tan positive. What positive, everyone? Tan positive. Tan positive means its partner cot is also positive. And finally, in the fourth quadrant, cos positive and its partner sec positive. Got it, everyone? So again, repeat. Here in the first quadrant, all positive, sine positive, cosec positive, tan cot positive, and cos sec positive. Okay, I just want you to remember only the first letter. Okay, so I can say like this. So let's put it this way. All positive A, sine positive S, tan positive T, and cos positive C. Because if sine positive, cosec is obviously positive. It's reciprocal. Okay, so how to remember this? There is a rule to remember all this quadrant rule. So can I write like this? A, S, T and C, isn't it? This is the abbreviation to all the letters in these quadrants, isn't it, everyone? It is this is the initials of all the letters in the quadrants. A stands for all positive, check this out. S stands for sign positive, T stands for tan positive, and C stands for cos positive. Okay, so how to remember this? There is a statement you can make, and we say add sugar to coffee. So this is how you remember. So don't say all sine, tan, and cos. You just simply say what, everyone? You say add sugar to coffee. Say add sugar to coffee, you'll remember the rule automatically. How? Let me write it here. So if you say add sugar to coffee, you have to write like this: add sugar to coffee. Check this out. How to decode this? A stands for all positive, S stands for sign positive, T stands for tan positive, and C stands for cos positive. Remember that. Add sugar to coffee. So if sine, obviously cosec. If tan, obviously cot. If cos, obviously sec. So this is how you remember. This is positive, by the way. Positive. Rest are all negative. So now if you ask me, what about the other other four? Here I have told you sine positive and cosec positive, isn't it? What about the rest? It's negative. Rest are all negative. Here tan and cot is positive, rest are all negative. In the fourth quadrant, cos and sec is positive, rest are all negative. Remember that. Okay, so again, so I want you to pause the video and copy this quadrant rule. It is very, very important. I want you to copy this figure here, whatever I have written, this statement including. Okay, copy this quadrant rule. It will be very, very important to simplify some higher trigonometric angles that we are going to do in this chapter. Having understood the quadrant rule, as you have I suppose already copied here, the rule says add sugar to coffee. So let us now learn something about higher angles in trigonometry. Okay, the first very simple question would be, in which quadrant does 560 and 1215 fall? So this is a very simple question. These are higher angles in trigonometry. Till now we were aware of only angles till 90, isn't it? Or maybe till 360 as well. Okay, but see what happens in trigonometry is, this is the quadrant, and let's say this is this. Let me draw a red line here. This is the red initial line. Okay, as this line moves, it will trace angle, isn't it? So once it reaches here, this is 45 degree, you know it. Once it reaches here, this everything is 90 degree. Once it reaches here, everything is 180 degree. Once it reaches here, it's 270 degree. Once it completes one full circle, it's 360. Now you may wonder, there will be nothing more than 360, but if it completes another round, okay, one more, let's say it reaches here now, one round, okay, it has already completed a round. Let's say it starts from here, completes a round, and then goes back again here. Okay, got it? Like this. So it starts from here, let me show you, like this. Starts from here, moves, and back again to 90. If this happens, then how much angle is traced by this line? It will be 360 plus of 90. Okay, so that will give you how much, everyone? Yes, that will be 450 degrees. So this way you can have any angles in trigonometry. Okay, whatever time the line rotates around the quadrant, it will form as high angle as possible. Okay, so it can form infinitely large angle also. Got it? So our job is to find the values of all those higher angles in this particular chapter. Okay, remember that. So this is how it works. Higher angle. So they are asking us, let me rub this, they are asking us here in this question, in which quadrant does 560 fall? Okay, so let me make a quadrant first of all. 560. Okay, so you know this is 90, 180, 270, 360, isn't it, everyone? You know so let me write it here: 90, 180, 270, and 360, isn't it? But 560 is greater than 360. So what will I do is to know, okay, to know in which quadrant does this 560 fall. What I have to do is I have to divide 560 into break this 560 into 90s. Okay, that means basically I need to divide this 560 into as many 90s as possible, in multiples of 90. Can I put it this way? Yes. So what I will do is I will divide 560 by 90 like this. Okay, that would be better. If you divide 560 by 90, then you will know how many quadrant does this cover. Okay, you can use your calculator. So if you divide 560 by 90, how much do you get? You're getting 6 times. Okay, because you know it, 6 9 is 54, so 540, and then what is the remainder? 20 degree. So you know that 560, check this out carefully, can be written as 6 times 90 plus extra of 20 degree. Did you understand? Express it in this way: 6 times of 90 plus 20 degrees extra, remainder is 20 degree. So how would you now move about this quadrant? Check this out: 190 means this much, 290, 3, 4, back again 5, back again 6. So when you do 6 times 90, it reaches here, it reaches this point. Did you see that? It reaches this point, but you have a 20 extra, a little extra, so it will come back to this quadrant. So ultimately 560 will be somewhere here. So which quadrant is that, everyone? 1, 2 and 3. So this lies in which quadrant, everyone? Third quadrant. So 560 lies in third quadrant. I hope you have understood this. Okay, so I want you to copy this question and understand this solution. Have you understood this, everyone? Yes. What about 1215? Next question says, in which quadrant does 1215 lie? Let's do the working here. Okay, so let me make the quadrant. Okay, this is 0, 90, 180 and 270. Okay, so what is it? 1250. Okay, what can you write? 1250. 1250 divided by, you have to divide by 90, by the way. Okay, it goes 13 times. Okay, 13 times. So 13 into 90 plus how much remainder? Just try it out, everyone. 13 into 90 would mean 1170 minus you have to do 1215. That's 45 degree extra. Got it? So check this out: 1250. Remember, you have to write it in terms of 9 multiples of 90, not anything else. Why? Because every gap here, do you see this? Every quadrant is a 90 degree each. Okay, so 13 times 90 plus 45 degree. How can I do? Like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. So 13 times 90 means first quadrant, plus 45 means it goes to the second quadrant. So which quadrant does this lie, everyone? It lies in the second quadrant. Okay, interesting thing to notice actually, when you come back to the initial line, so see 1, 2, 3 and 4. So this line is actually the multiples of 4. 4 will come here, 8 will come here, 12 will come here, 16, 20, multiples of all the multiples of 4 is the initial line. Okay, like 1, 2, 3, 4, again 5, 6, 7 and 8, it reaches here. Okay, all the multiples of 4 will be on this initial line if you have to ever count. So just a example, what will be 16 times 90 plus 25 degree? Just an example. Okay, 16 times 90 means this line, first line, isn't it? Because any multiple of 90 will reach here. 16, got it? Plus 25 means back again in the first quadrant. So I easily know this is in the first quadrant, because even if you calculate, even, okay, let me show you, even if you do the necessary calculation, let's say like this, like I have done earlier, by counting the quadrants: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 will be here. You'll completely cover, and plus something means again in the first quadrant. Okay, so this is how this locating higher angles in the quadrant, this is how it works. Okay. Okay, also to end today's class, I would like to give you some trigonometric ratios of negative angles. I want you to copy this in your notebook. There are 6 such formulas, so very, very important. Okay, so we also have to frame a formula for negative angles, and the first formula is, what will happen if you ever get sine of minus theta ever? So what will happen? This will be minus sine theta. Remember, the negative sign is popped, it will throw out the negative sign, it pops out. Okay, number 2, what happens of to cos of minus theta? For this, it will only become cos theta. Remember, it will absorb the sign, no more minus coming out. Okay, it will automatically gets absorbed. Okay, the third one, what about tan of minus theta? It will be minus tan theta, it pops out again. Number 4, cosec minus theta, it pops out, minus cosec theta. Check this out again, it comes out. Number 5, sec of minus theta. This is interesting. Sec also, the sign gets absorbed. And finally number 6, cot of minus theta, minus of cot theta. Okay, so if you look carefully, there are only 2 ratios where you may say the sign gets absorbed, and that is cos and sec. So these two are very, very important. In cos and sec, the minus sign gets absorbed, whereas in sine and sine, tan, cosec and cot, the minus sign gets thrown out. Okay, an example would be if you have sine minus 60, then it will be minus sine 60, and that's equal to, what is sine 60, everyone? Minus root 3 by 2, like this. But same thing, if you have cos minus 60, then it will no longer be minus cos 60, it will be simply be cos 60, and the answer will be half. Okay, no more minus popping out. So in sine, tan, cosec and cot, minus pops out, whereas in cos and sec, it gets absorbed. Remember this formula. So we will solve sums in the next class.